Now let's take a look at why we would use frame relay subinterfaces. Frame relay by default is a non-broadcast multi-access environment. It's important to take note of the type of topology that's used in your company when choosing frame relay. Most frame relay implementations will use the hub and spoke topology due to cost limitations. Oftentimes there would be the partial mesh. Ideally, we would have a meshed environment, but due to cost restraints, most environments will choose the hub and spoke topology. Let's take a look at the specifics of how this topology affects frame relay data flow. As I mentioned, frame relay is a non-broadcast multi-access environment. Here we have a hub and spoke topology where router A is the hub and routers B and C are the spokes. We have a PVC here and a PVC here. Being a multi-access environment means that all of these devices appear as if they're in one common layer 2 environment. Being non-broadcast means that when one device sends a broadcast, the other devices won't necessarily all receive that broadcast, because what happens is router B sends a broadcast and router A would receive it, but router C will not receive that broadcast. So therefore we have a non-broadcast multi-access environment. The key issue comes up when we run into routing updates. When router B sends a routing update to router A, indicating the networks that router B knows about, router A would have to make a copy of that broadcast and send out that copy to router C in order for router C to know about the networks that are out here on router B. However, the problem is if the packet comes in to router A and now router A has to replicate that same packet to send it out, both of those are going across the same physical interface. Split horizon, you'll recall, says don't tell me what I just told you. Split horizon says it's never useful to send out a packet over the same interface that it came in on. So split horizon would cause reachability issues in this frame relay non-broadcast multi-access environment. So what we do to overcome the split horizon situation there is that we divide this physical interface into multiple sub-interfaces. Looking specifically at router A here, here's router A, here's that physical interface of serial 0. What we want to do is we're going to divide serial 0 into two sub-interfaces. So we would have serial 0.1 and serial 0.2. Serial 0.1 would be assigned to this Dulce, we'll call it Dulce 100 going to router B, and then Dulce 200 going to router C will associate with serial 0.2. That way, when router B sends a routing update to router A is able to replicate that routing update and send it out to router C without split horizon controlling the routing update. So the packet comes in, the update comes in on serial 0.1 and can be replicated and sent out of serial 0.2. So keep in mind, split horizon can create reachability issues in a frame relay non-broadcast multi-access environment. We use sub-interfaces to overcome that limitation.